Okay, guys, now that we've seen the demonstration, let's work on some Boyle's Law problems with volume and the pressure of a gas at one point, and then see if we can find the pressure and volume of the same gas at another point. All right, so pressure and volume problems. Example A. A container of oxygen has a volume of 3.30 liters and a pressure of 4 atmospheres at room temperature. All right, so this would be volume 1, and this would be pressure 1, because the pressure and the volume occur at the same moment, so we give them the same subscript. It says this is going on at room temperature. Okay, and I guess it's going to stay at room temperature. That will be constant. If the pressure of the oxygen gas is reduced to 2 atmospheres, so this is the after pressure, we'll just call it P2, and the temperature is constant, what is the new volume? All right, the new volume is going to be V2, and this is what we don't know. All right, so that's just reading the problem. We've gotten this far. So the conditions of the particles at this first state, 4, we're calling 1. The pressure at 1 is 4.00 atmospheres, and the volume at that is 3.30 liters. Liters is 1 liter equals 1,000 milliliters. All right. Milli meaning 1,000th of a liter. If the pressure of the oxygen gas is reduced to 2, so afterwards the pressure is only half of what it was, what should happen to the volume? So V2 is what we don't know. That's our unknown. One thing to look at is the pressure of the sample was reduced. All right, it went down. It was halved from 4 to 2. So the volume will go up. The volume will go up, and it should be twice as big. Twice the original volume. So let's go see if that's true. All right, we know from our gas law that the pressure at any point times the volume at that same point equals the pressure at a second point times the volume of a gas at that same point. So these two are related by the fact that if we had done a graph, they would be on the same line. The slope is the same. All right, so we want to know what V2 is. So this is what we're looking for. So V2 is going to equal, let's divide both sides by P2, and we end up with P1 V1 over P2. All right, when I divided this side by V2, we were just left with P2. All right, so we divide through by this. We divide through by this. All right, and so it becomes in the denominator over here, and this over itself will just be 1. So the first pressure is 4.00 atmospheres. All right, times the volume. First volume, 3.30 liters. And then we'll divide by P2 here. And P2 is the second, and it was reduced to only 2 atmospheres. I think when you look at this now, we're looking at the fact that the atmospheres cancels. All right. And here again, we're noticing that 4 over 2 is going to give us 2. But let's just go ahead and do this calculation. All right, so 4.00 times 3.30 divided by 2.00 equals 6.6, and the unit that is left is liter. All right. And this, of course, was 2.00, 4.00, 3.30. All of them have 3 digits. So our answer should also have 3 digits. So we will put a 0 on there to get to 6.60. Oh, there it is. I see. Let me do this. There. It was too short. There we go. 6.2 liters. All right. Now, so our final answer is 6.60 liters. We said that if we halved the pressure, we should double the volume, and indeed, that's exactly what we did. We doubled the volume. All right, if we're doubling the volume of 3.30, then we'd have 6.60. So this one you could have predicted very easily yourself, couldn't you have? Yeah, you could have. All right, but I wanted to show you the whole problem. Now, let's go up to our rubric over here. It says, when we do problems, the first thing we do is mark the variables, pressure 1, volume 1, and then afterwards pressure 2, volume 2 in the word problem. We mark them and then we transfer them to the charts. All right, so that's what we did here. All right, we marked them in the problem. And it has a volume of, so we knew just by the fact it said a volume of that we were talking about volume, correct? All right. A pressure of 4. All right. And the unit was over here of atmospheres, a typical pressure unit. It says it's room temperature now, and it says the temperature is kept constant. And so also the number of particles is kept constant. So now if the pressure of the oxygen gas is reduced to 2.00 atmospheres, all right, there's the second pressure, then what is the new volume? All right. So that's how we got these from, and then I transferred them into this table. All right. And then we did the same thing here, and the table said atmospheres. This said liters, and both pressures were in the same unit. All right, atmospheres. In order for the problem to work, these must be in the same unit. All right, now what do? We just earned some points for that. Half a point. Now we write the correct equation with pressure and volume variables on both sides to solve the problem. So here is that. We finished this, all right? P1 times V1 equals P2 times V2. And remember, we learned this. We figured it out from the graph we did of pressure and volume, that this was the relationship. All right, V2 is what we want to know. So getting this all by itself over here, then we would have P1 times V1, same thing as over here, but we'd want to divide by what's on top over here, P2. All right, now we would simply put the numbers in. 4 atmospheres times 3.30 liters divided by 2.0 atmospheres. We see that these are canceled out, and so liter will be the final unit. All right, so we wrote the numbers in for the variables. All right, after we put it in, so here's where I did that. After I figured out the equation and the correct one for us, I put the numbers in from the problem. All right, and then we did the calculation. All right. And you'd get all of the points. And we know we needed 3 digits and we needed the correct unit. We got the correct unit right here and we got 3 digits. Now, for anybody who thinks this is easy, it's only easy because you probably like math. For the rest of you, you just have to be persistent in doing all of these little steps. All right, then it becomes easy. But you have to be meticulous. All right. We're going to be doing math throughout the entire year, so it's worth it learning how to do this. All right, so do these problems in the same manner. The goal, remember, is for you to show me how you picked out the variables, how you write the equation with the variable names, and how you put the numbers in that replace the variables. All right, and then you get the final answer in the correct number of significant digits and the right number. All right, so let's read the next one aloud. A gas takes up this many liters. So you can go ahead and do this. At a pressure of, oh, this is a different, yes, pressure unit. All right, this is millimeters of mercury, as in a barometer. The temperature is 280 Kelvin. All right, that's a little bit cooler than room temperature. What is the new pressure when the volume is changed to 9.82 liters? All right, so what's the new pressure? That's what we don't know. And in fact, we could put it in. Let's put new pressure, and we'll make it this. All right, that's what we don't know. So let's look at these numbers. All right, it says the gas takes up 12.0 liters before. All right, let's put these in. 12.0 liters at a pressure of 540. These are the two numbers that go together. This is the pressure that goes with that volume. And it's 0.0, and it isn't atmospheres, it's millimeters of mercury. All right, 1 atmosphere is equivalent to 760 millimeters of mercury. All right, this is standard air pressure. Why don't you write that down? It says, what's the new pressure? What's the new pressure then when the volume in the system is now 9.82 liters? Oh, at least we kept the same unit of liters, right? All right. So 540 is pretty low pressure, isn't it? If 760 is equivalent to 1 atmosphere. All right, so we don't have to convert this to atmospheres. We will just get a pressure in the same units as millimeters of mercury. All right, so this question says, what happens to the volume of the sample? Well, did the volume of the sample go up or down from V1 to V2? Well, the volume of the sample went down, decreased, right? So we know the pressure will increase because they're inverse. All right, so that gives us an idea that our answer should be bigger than 540 millimeters of mercury. All right, so what do? Well, we just write that equation, P1 times V1 that we got equals a constant, and that's why it was equal to the second pressure times the second volume at another point. And now that we have that, what is it we're trying to find? Oh, we're trying to find this. This is P2. The before is the 1, and the after is the 2 variable, second variable. All right, so what we want is this. So P2 is just we'll divide both sides by V2. All right, and see how those cancel. So let's now go over here. So the P2 is going to be P1, 540.0 millimeters of mercury. Now remember, I'm wanting you to do exactly what I do. And some of you are fudging. So P1 times V1 is 12.0 liters, correct? And then we're going to divide by V2, which is 9.82 liters. All right. Liters is going to cancel, and this will be the final unit. So whatever we get the number of, it will be in units of millimeters of mercury. All right, so right here, let's put 540 and multiply it by 12.0 and then divide by 9.82 equals 9.82. Oh, I've got that there instead. I need to put a times. All right, now that should be okay. When I press enter, I get 659. Oh my goodness, look at all those digits. And that's in millimeters of mercury. So I'm going to round to 3 digits. This has 4 digits, 3 digits, 3 digits. So I'm going to have to round it to 659.9, and that's going to round to 660 millimeters of mercury. Hg is the symbol for mercury. Now, there's no reason to throw numbers around and get this done rapidly. I mean, we're not going to a fire, hopefully. So, I want you to go ahead and look over this problem. I want you to just read it right now and do the underlining yourself. And I will wait while you do that. So go ahead, read the problem, and figure out what you've got. So it's telling us that a gas at 25 degrees Celsius, this is room temperature, takes up 3.60 liters of space. All right. And the pressure at that point is 1.00 atmosphere. So now we have V1 and P1. Now it says what will be its new volume. So that's what we won't know, right? At a pressure when it's 2.50 atmospheres. All right. All right. Now, it's extraneous that it tells us it's room temperature, but we want to know the conditions just like we did in the simulations. So when all this is going on, and temperature and number of particles are held constant, what is the temperature? So that's why it's telling us this. This is just one of those things that's being held constant. All right. Whoops, that's not what I meant to do. All right, so this is just a constant up here. Because remember, we're doing pressure and volume, right? Yeah, so any other number we get is just telling us what is constant. So let's now start filling this in. It says a gas has 3.60 liters. All right. 3.60 liters of space at the corresponding pressure is 1.1. So this is the before. Let me come back up here again. Something went crazy. All right, and then this is the after. So that's the first one, and that's the second set of conditions. All right, now we have 1 and 3.6 atmospheres, and then the pressure afterwards is 2.50 atmospheres. Oh my gosh. And then we don't know what that is. So then it says, it wants us to look at this and say, what happened to the pressure? Well, it went from 1 to 2.5. So the pressure went up, and it's times 2.5. Bigger. Yeah, 2.5 times bigger. So the volume will go down because they're inverse. All right, and it should be 1 over 2.5 times smaller. So let's work this out and see how that works. So it's easier for me to write than it is to type these equations out. So we know, as always, P1 times V1 equals P2 times V2. All right, we don't know what P2 is. Excuse me, we don't know what V2 is. So this is the guy we want to put by himself. So we'll divide through, all right, by P2. And we end up with P1 times V1 over P2 equals P2 over P2. All right. So I did all my points. I figured out, I put the equation down with the variables of pressure and volume. Then I just made it to the point that the equation is showing me what numbers I multiply and what I divide by. And remember, that's what students always want to know. So P1 is 1.00, and the unit is atmosphere, times V1, and the unit is 3.60 liters, divided by P2, which is, what's the second pressure? 2.50 atmospheres. All right. Now we can see that this cancels, and the final unit will be liters. All right, so let's do 1.00 times 3.60 divided by 2.50. I'm going to look and make sure that I typed what I thought I did. And my answer is 1.4. Remember how I said it should be smaller than 3.6? It's 1.4. And since we have 3 numbers here and 3 numbers here, I know that our final one can have 3 digits, so I'll answer that, and we know that liters is the final unit. So you see, it's all about the evidence. We have to have evidence for the unit, evidence for the final answer. That's why you're showing me the equation with variables, and then you're putting the numbers in that came from the problem. Now, the question we asked before was, let me find my calculator. Whoops, here it is. All right, I think I'm going to open Logger Pro too, and I didn't mean to. All right, I said that the final volume should have been 1 over 2.5, which is 0.4 times the original volume of 3.6, 1.44. I can't see, so I must have made some mistake there. But 1.4 is about what we should have gotten, and that's what I was checking. So when we had the pressure went up 2.5 times bigger, then the volume should go down by 1 over 2.5. That's what the inverse relationship tells us. All right, so this is what you need to do. So let's go down and look at the rest of these. Go ahead and read the problem. All right, go ahead and now do the same thing I was doing. All right, this is great because this has the volume and the pressure in one fell swoop, like that. All right. What will be the volume of this gas if the pressure becomes 3 atmospheres? What will be the volume? All right, that's our question. What will be the volume? All right, now what I'd like you to do is figure out what is the unit of the pressure. All right, and we'll go in the problem. There's 1 atmosphere here and an atmosphere here. So go ahead and put atmosphere as the unit of pressure. The unit of volume is liters. So we will get our final answer in units of liters as well. All right, did you put ATM there? All right. Now you go ahead and fill in the table where becomes the first set of conditions and this becomes the second set. I do 1 and 2 because isn't that easier than writing before and after? That's the reason we usually do that. All right, put the numbers in. Figure out what it is we're looking for. All right, now it says the pressure of the sample does something, so the volume will also do something. So figure that out now. If the pressure started at 1 atmosphere and it becomes 3 atmospheres, it's gone up, right? So if it's gone up by 3, it's bigger by 3, then the volume will be down by 1/3. Will be 1/3 of what it was originally. All right, that's what I want you to see. By filling this out and knowing that pressure and volume are inverses, you're able to think. Now, those of you who are thinking this is all gobbledygook, all you have to do is calmly think and just accept, well, this is the way it is. There's nothing to memorize. You're just thinking through the problem. All right, now fill in the blanks. Okay. Now you know the equation is always the same thing, right? P1 times V1 equals P2 times V2. Write that down. Then you'll know what you're looking for. Some people prefer to just put the numbers in because they find it easier to do the algebra on real numbers than just on variables. All right, so go ahead and do that. Put the real numbers in when you're done. And then you can use the calculator that I've asked you to put on your taskbar. Or you can use OneNote to do the calculations. All right, and whenever you use OneNote, you always use a little X for a times symbol and the slash for divide. All right, so go ahead and finish that. I'm going to go on, so you'll want to stop this now. All right, while you finish the problem, and then turn it back on to listen to the next problem. All right, so 4 says, a gas occupies 11.2 liters at 8.60 atmosphere. Oh, I love it when they put the conditions together like this. All right, what is the pressure? Oh, what is the pressure indicates this is something new, right? If the volume becomes 15 liters. All right, and now we're beginning to say, oh, I know that's volume anyway, because if it has liter for a unit, it must be. Now, I want you to figure this out. The volume of the sample, what happens to the volume? And so what should happen to the pressure, the thing we're looking for? All right, now it looks like the pressure unit. Let's look and make sure they're the same one. Oh, atmospheres. All right, so you want to put atmosphere in here, ATM. All right, I guess I gave too much space here. All right, volume. Let's see what it is. Oh, it's going to be in liters, and it's in liters here. Thank goodness it's the same unit. We don't then have to worry about that. Okay, now fill this out and search for the appropriate numbers to put in the equation that you wrote down. The relationship of the first pressure and volume and the second pressure and volume conditions. So remember, we have to stay in the same units for pressure before and after. All right, now stop the video again and we'll let you work on the problem. All right. Now, for the fifth problem, it says we have a sample of 500 milliliters of a gas collected at 745 millimeters of mercury, and the sample is 500 milliliters. All right, so we have milliliters as the unit for volume and millimeters of mercury as the unit for pressure. And it says this is occurring at 0 degrees. All right, we know that's freezing. All right, so we will just put, all right, to indicate this extra variable is just telling us that the temperature is remaining constant, and it's doing so at 0 degrees Celsius. What will the volume be when the new pressure is standard pressure? Oh, now this is getting a little more complicated, isn't it? Because it's expecting us to know something. Well, Standard pressure. Let's see. Let's go up and see if we talked about this before. Oh, standard air pressure is 1.00 atmospheres, or it is 760 millimeters of mercury. Remember that the pressure we're talking about now is in millimeters of mercury, so we want 760.0. All right. We want 760.0 millimeters of mercury. That's standard pressure. All right. So the pressure of the sample, let me put this in red because I think I did every other time. All right. What happened to the pressure of the sample? It went from 745 to 760, didn't it? It went up. The pressure went up. So what should happen to the volume? The pressure went up a little, so what happens to the volume will be a little bit too, but will it be up or down, increase or decrease? All right, so you go ahead and solve that. All right, so I hope this problem-solving session worked well with me just talking you through it calmly. All right, talk to you very soon. Bye. I think I just did that whole thing without recording it.